Hello everyone. In this video, I'll be walking you through how to create a photovoltaic facade in Rhino and Grasshopper using parametric design. This project is a great starting point for beginners in parametric design. If you are interested in seeing more projects in computational design, be sure to subscribe to the channel. I have already created a similar model and today we'll be building it from scratch in Grasshopper. If you are new to Grasshopper and Rhino, I recommend checking out some introductory tutorials first, because I'll be only covering specific components which are needed for this project. So we are going to create a solar facade where all the panels will be oriented towards the sun to capture maximum energy. And you can see here from the model I have created, if I change the start month, you see the panels are moving or orienting. I can just actually turn on the vectors to show you a better view. Yeah, now you can see that the panels are facing towards the sun, and also it works if I even change the hours. You can use this to animate for your final project, or you can play with these values later. So I will start by creating a new project, and now we have to create a surface, draw a polyline. I mean, you can draw a surface directly here, or you can use curves or lines. I'm just going to draw a line. Uh, yeah, and I'm going to what I'm going to do is I'm going to duplicate this and I'm going to loft the lines so we'll have a surface. So yes, now we have two lines and I'll just type loft, and you don't have to change any of the options here. Just click on loft and you will have the lines are joined. It's a closed surface. You can change the view if you want. You can go to render, you can go to ghost state, whatever you wish to work on. So I'm going to work on shaded. So I'm going to divide the surface. For that, I have to record the surface in Grasshopper, and I'll go to Grasshopper and I'll press space to search, or you can just go to params and you can find surface here. You can just click on it. So to refer the surface, you click on right click on it and select one surface and click on this. Now you have selected the surface, and now what I'm going to do is I'm going to divide the surface. For that, you can go to surface and use divide surface or surface lines, or you can just type in here surface. I'm going with surface range as of now. Connect the surface, and you will have two other options as well, like U count and V count. That means how many divisions you want on the surface in both directions. So I'm going to slider. If you press 20, then you will automatically, if you press any number, then you will automatically add a slider. So I'm going with 20. And you, and copy paste. Same goes for V. Yep. Looks like too much, and I'm going to change the U to 10 probably. Yeah, and this to what? Let's leave it at 20 now. For now, we can change it later as well. Now you can see we have different planes showing up as frames. Now you can see that these are sticking onto the surface. See? So what I'm going to do is I'm going to move these. For that again, I'm going to type in move. You can see this move. Uh, I want to move these surfaces, the output, along. Like you can see, it's moving along the z-axis. So I want them to move along this axis, probably y, I guess. For that, I'll go with unit. You can see we have different axes here, and we're going to do it with y. Yeah. Yes. And when I input this y-axis, it's going with the positive direction, but we want the panels to be facing in the opposite direction. So I'm going to create a slider again. Um, let's say 2. And you can see here is positive value, so I'll double click on slider, go to options, and I'll change the values. So yeah, I'm going to hide these, the old ones. Now we have the panels which are positioned at some distance from the surface. We need some base for the panels. To create that, I will going to create a line between 2 points. From there to the new frames. So now you can see we have some lines. What we can do is we can just see how attractor point works. So for that, I'm going to create a point. So I'm going to create a point in Rhino. One point. I'm going to just move it in Z. If you're familiar with vectors, you know that they are on geometry and you cannot see them. We are going to create a vector from this point to the surface frames we have. So for that we want vector between 2 points. Here you can see we have 3 inputs. We just need 2 points, right? Point A, base point, and tip point. So base point will be the new frames, and the tip point will be the point we just created. We could consider this point as sun. We have a component called vector display. You can see it here. Yes. So it also takes 2 anchor point for preview vector and vector to preview. So we already have this vector created. So I'm going to plug in the vector here, and anchor points mean from where we want the vectors to start from. So it's the plane. Yeah. So now you can see all these vectors are pointing towards the point. If I move the point, since we already have created the vector, you can see all the lines are following the point. We are going to use this attractor point as a sun. So I'm going to just create a rectangle. So I'm going to plug in this. So now you can see we have created some rectangles, and I'm going to create boundary surfaces which will close this surface. Now you can see it's an outline of, like it's not closed surface. The rectangle has some default values, so they are overlapping each other, but we'll change it later. If I change it, they are not following because they already have default vectors in x, y, and z direction. But we want our panels to move along with this. So what we can do is we can consider these vectors as one of the axes. If we make this one of the axes of the surface, then we'll have the other axes perpendicular to each other. So when I move the point, the surface also moves. Component called normal plane, plane normal, where you can just plug in the origin. Origin will be this, right? And so we can consider these vectors as zeros, and I will plug in the Z. And I will plug in this plane to the rectangle. Yeah. So now you can see all the rectangles are oriented towards the sun. If I move it, now you can see all the planes are, all the rectangles are pointed towards the sun. The thing is that there is an issue. What we want to do is they have to rotate in one axis and they have to tilt in another axis. Or suppose we already consider vectors pointed towards the sun will be z axis, so we want the planes to be rotating in x axis, or suppose, and tilting in y axis. So what we're going to do is that we're going to rotate this because this is not our ideal solution. We will construct a plane in z-axis and use the vectors as y-axis. So origin points will be the same. Yeah, as I mentioned, we'll have the x-axis as z, right? So z will be the x-axis, and y-axis will be our sun vectors. And change the orientation towards this attractor point. So from this, since we already have x and y, get a new z-axis. I'm going to deconstruct a plane and see what is our new z-axis. And just do copy paste of this vector. So this will be the origin, and see we already used z-axis as x-axis, so that is our new x, and y will be our towards the attractor point, and z will be our new vector. So for this, we already have our z-axis for the final plane as which are these vectors. So we can consider the z now, the new vectors which we have created as x-axis for the final plane. And since we have our x-axis, I'm going to construct a new plane, copy paste, which is the same origin, and x as this new vector, and y as the final vectors, the vectors which are pointed towards the sun vectors. And again, you can see these planes are in different axes, but they are all oriented towards the sun. Since we already gave 2, we are going to get a new vector, which will be our y vector for the final plane. So I'm going to plug in this, and again I'm going to do the same thing. I'm just going to disable this so it will be clear for us to understand. So yeah, if you see, these are our x-axis, and these are our y-axis, which are to point towards the sun, and z will be our new axis. So what we are going to do is that since we have considered these vectors as x-axis vectors, and we already have z vectors as sun vectors, and the vector which we have which we got now will be our y vector for the final plane. So I'm going to do that, construct a plane, or just copy paste this, right? I'm going to copy paste this. Origin will be from those points, and x is this, right? And z and y will be the new vectors. To preview. I'm going to disable these, or we can just delete this video. We have no use of them right now. Now we have our final planes, which are pointing towards the sun by rotating in one axis and tilting in other axis. I'm going to plug in the rectangles to the final planes that we have now. Here are final planes, which are rotating in one axis and tilting in another axis with no weird orientation. Since these are all up, I'm going to change the sizes. You can use X and Y size here as inputs, and further you can see that they will take a domain value, I mean, from negative value to positive value. See one locally defined value -1 to 1. So further, what I could do is I could create a domain, construct domain. What domain does is that it takes two values, uses it as input. Like you can give one input with two values. So I'm going to just plug in this in X, copy paste, and Y as well. Now, if you see this, it's scaling from the center because we have not given any inputs to these. So for that, I'm going to do a scale. It should be two or something. Two will be good enough, I guess. Let's see. I want this to be native. Okay. Native 2 and 2. If I do that, you can see that in x-axis, in x direction, you can see the plane is centered. I'm going to do the same for y as well. Instead of creating these, I'm going to use expression. I'm just going to type expression. For this, if you zoom in, you can see these. What I'm going to do is that I'm going to create an expression which will take this input and divide it by half or multiply it by half. So the input is x, right? Yeah, x. And also I want a native value, right? So I'm going to change this to native 0.5. Right. Okay. I'm just going to plug in this. Yeah. Why I'm having two different sliders is you can control your x and y inputs differently. Like if you want to scale in x in one value, and if you want to scale your y in different value, then you can do that with this. See, you can see now, since I have reduced the amount by half, then we have good plane size. This is all. Like, I think we need more control, so I'm going to read it as rounding numbers. So we'll have some decimal values. Now we can just do this. Let's go with 2.5 something. Next also. I forgot to change this to rounding number. Yeah. I think 2.5 will be good. Now we have completed our final model. You can change the point position to see if all the rectangles are behaving. And once we are done with it, we can proceed to the next part of this project. And for the next part, what we are going to do is we are going to use Ladybug, which I have here, which is a plugin. You can download it. We are going to do environmental analysis. It will be a short video because we are not going too much deeper.